It disturbs the network.
Teacher Dave, what software do you use to record?
It's a software that it's in Google Meet. So it comes with the Google Meet. You install it.
Okay.
It's those
If you ever have chance, you can install OBS. It's also really easy to use. I don't know.
OB. Oh,
OBS.
I used to use that,
OBS.
but the audio was low.
Oh,
The audio was low. That's why I decided to get this one. This one, the problem is when I start recording, it chows data. So when you record online, that's what happens. So it records online, so it chows data. While if the network is bad and I record, it disturbs the network worse.
yo.
It disturbs the
Okay.
network worse. That's why when I start recording, it's a problem. But we have to fight with this thing. There's no other way. So guys, yeah, someone was asking you a question. He said something about the assignment, or I can't remember.
This was Sabaya. He just wanted to know what date is the assignment, and Pitsy told us that she emailed the lecturer for late registrations, and it's the 14th of March.
Oh, so you guys still have time, Miss? We don't have to
Yes.
rush. Okay, then let's work, guys. There's no. I thought maybe you guys are submitting the assignment. Then let's work. We have got enough time, Miss. Okay, let's push then. So, guys, this session will be on every Monday, ne? Yeah.
I'm sorry to interrupt, but I think it only applies to those who have registration. Because if I check on my uni site, still give me I think Friday.
Yeah, they won't update it until the lecture will report to the guys who are doing those things. They will update it. Don't worry. They'll have to extend it for everyone. They don't only extend for those who registered late. No, they extend for everyone. So just okay, for your own safety, you can submit when you're done. Just push it. Even if you finish early, it's fine. Just push it. Okay, so guys, let's work. Uh, so now you've got this and this. You are adding this and this. So the first thing that you must do, guys, look at this. You've got root 4, negative 4. So if you've got a negative root of a number, any number, it can be any number. If you punch it on the calculator, guys, it will give you an error. It will give you an error. So you need to change this to positive root. So you're going to do this. You're going to say root 4 multiply by root negative 1. Do you guys agree that this is the same as root negative 4? So you just split them. So you must know that square root of negative 1 is equals to I. All these things that I'm doing, they are here on your formula sheet. You see, where is it? You see there where it says I squared is equals to negative 1. I squared is equals to negative 1. So they say I squared is equals to negative 1. But in our case, we have got only I. So if this was I squared, then you say square root of negative 1. Remember, we said I is equals to square root of negative 1. You must know that. But then now we've got squared. So we have to square both sides. So you're going to get negative 1 when you square. Because 2 and square root will cancel. Do you guys know why 2 and square root cancels, right? I think you still remember that square root is half. Yes. Square root is half. Yes. So that's why you got that negative 1. Now, you see why this I is equals to square root of negative 1. You must know that. You must remember it. So there where there is square root of negative 4, we're going to have to replace it. So here we're going to have 3 plus. Okay, let's group the like terms. Instead of doing this, let's just group the like terms. Because we know that this, we can write it as, what is the square root of 4? It's 2, right? So you're going to have 2i for this one. You guys know how we got 2i? Yeah.
No, teacher Dave.
Okay. So we said 4 times square root of -1. So 4 times square root of -1, you're going to get 2 for this 4. You're going to get square root of 4, you're going to get a 2. And then we said where there's minus square root of -1, you're going to get I.
Okay.
Sure. That's how you do it.
Thank you, teacher Dave.
Sure. So we're going to replace those values there. So let me just rewrite this thing. 3 plus 2I plus 2 minus 2I. So right now, guys, I'm not going to do... Okay, I'll have to do it. Since you said your assignment is due later, then at least we can have enough time. I'll do subtraction, addition, multiplication using different methods. So I'm going to show you up to exponential now. I'm going to do it up until exponential, part for exponential. So you do the same thing. You group the like terms here. You add. So you're going to say I. You add the I values is 2 minus 2. Okay. And then you say plus, open bracket. You add the real numbers. You add 3 and 2. So you're going to have 3 plus 2. Then your z equals to 0 plus 5. So in this case, you only have got 5. Z equals to 5. So you don't have the I values because it's 0. Even when you do your what do you call it? When you convert this thing to polar, you must get a value like this. So let's go and convert it to polar. So we agreed that you have got 0I there. You must add that. You must put that 0I there. So this is your rectangular form. This is how you do rectangular. They normally say there's this word that they use, conjugated. Is it conjugated? Sometimes they say, they don't say rectangular. They say what? You must know that is the same thing as rectangular. If they say conjugated or something, I can't remember that word. But that's rectangular. That's all. So this thing is Z is the same as Z equals to A plus BI. So now I'm going to convert this to polar. From polar, I'm going to go to uh, from polar, I'm gonna go to what do you call it? I'm gonna go to exponential. Okay, so in formula form, we're gonna have to go to R, that's your polar, and then your exponential, it's that one where you've got R e to the power. Is it theta? This one, this formula, I theta there. That formula that I've just highlighted in blue. You write I there. So let's convert that 5 plus, so you've got 5 plus 0 I equals to z. So you want to move from rectangular to polar. So when you move from rectangular to polar, they told you that the formula for polar is this one. So you need R. You need R. Ash, what did I do now? Messed up. So you need R. So you're gonna have to find your R. So R is equals to square root. You do the same thing that we did earlier. Ash, why do I keep on doing this thing? So your R is going to be equals to 0 plus 5 squared. Then you're going to get, your R is going to be 5. Your R is 5. Then from this, you know that you need theta. So to get theta, I showed you that you must say tan equals to opposite over adjacent. So your opposite in this case, you must know that your opposite, there's your A, there's your B. So basically there's your A, there's your B. It's opposite of adjacent. If you draw this on the that argument agenda diagram, this one, your 0, it's 5 and 0, so it's more like it's a straight line. It's 5 and 0. Then this 5 is somewhere here. So the 5 is your A. So you see there, I can't erase this thing. Right?
Sorry,
Then,
before you continue,
sorry?
how do you draw your triangle there if the B is 0?
If the B is 0, you see the problem, if the B is 0, your I is here, your triangle, you won't be able to draw this triangle. That's the problem. That's why I wrote a dot there. 5. This 5 is for, it's for your real numbers. Real numbers. It's very rare to get this question. You can't get such questions. It's very rare to find this one. Because clearly this means that your angle is gonna be 0. That's why you found 0 I there. Your angle is gonna be 0, obviously. So this thing will take you back to, you will see that the polar and the rectangular, they are the same. I wanted to show you that if one of the two values is 0, your angle is gonna be 0, even, and then your r is gonna be that other number. I don't know if you get my point.
Okay.
Do you understand what I mean?
Is it not gonna be the square root of that number?
Yeah, if you square this thing, you're gonna get 5. It's gonna take you back
Oh, yeah.
because because
Because of
5,
the square root.
yeah. So that's, this one is, I just wanted to show you that if you've got something like this, you don't have to worry. But then you guys won't get this thing. Very, it's very rare to find this thing. There's nothing to solve there. So I'm gonna take this one. I want to show you. I'm gonna take, guys, this thing, I getting mixed up. I don't know what's happening. Mm, wait, where are those values? You guys still remember the values that we got when we were doing? I want to continue with that one. Convert this thing to rectangular. Where is it? It's this one. I want to copy this, paste it here. Okay. So guys, this thing is already solved. You guys still have those values, right? This thing is already solved. I want you to convert this thing to rectangle, to, we converted to polar. I showed you how to convert it to polar. So now convert this thing to exponential. We are converting this thing to exponentials. Then from exponential, I'm going to show you how to go back. How to go back to polar from exponential. So exponential, the formula was like this. R E, it was R E I theta. So the values for this thing, you guys got them. I think it was 5. Z was equals to 5.1. Then this one was, what was this? 11 point, minus 11 point, sorry? 31, right?
It was 11.31.
Yeah, degrees. Thank you. So look at this. You've got your R there. You'll be surprised. Why are they looking for this thing? Because this is the same as R theta. You see this? When you're doing exponential, this angle, it must be in radius. That's the difference between the exponential and the polar. The angle for exponential, always, guys, it must be in radius. But the angle for polar, it's in degrees. It's in degrees. This one it's degrees. This one it's red. That's the difference. So now if you want to convert from polar to rectangular to exponential, so it's from polar to exponential to exponential, you have to convert the angle from degrees to polar. So from degrees to radius, because you've got r. So let's convert that angle. The formula to convert from degrees to radius, this is the formula. So you're gonna say rad equals to your degree angle times pi over 180. This formula is here. Let me show you the formula. It's here. I can't remember the page number, but then it's there. I don't know if anyone saw this formula. It's under exponential. Just to highlight this formula so that you don't forget it. It should be somewhere here. There is the formula, guys. Please highlight this formula. You see there on page 112. That's how you convert. You see this formula. That's 60 degrees. That's your degree angle. You see, they say the angle there in exponential form, the angle must be in radians. That's what I said. In exponential form, that angle must be in radian. And then this is the formula to convert to radian. That's the formula. So you have got
today,
yes.
Is that 180 degrees constant? Is that the pi over 180?
It's pi over 180, yes.
Okay.
So from page 112.
Which?
Page 112. So it's pi over 180. That's the formula. It's a standard formula. It's like this. Whatever degree angle you've got, you're going to multiply it with pi over 180. Yes. So the answer that you're going to get here, you're going to say minus 11.31. It's in degrees. Multiply by pi over 180. You just punch this on your calculator. You'll get negative something something.
I got minus 0.197.
Minus 0.197.
73. So
Minus
it's 1.2. Minus 0.121. Is it minus 0.2? Sorry.
minus 0.2.
Yeah.
Yeah, you can round it off to one decimal. So it's in red, ne? So now you can go back and substitute those values. You can say your R, it was 5.1, then e to the power minus I 0.2. That's how you do exponential. So now guys, if they gave you exponential like this, then they say convert it back to polar. Or let's make it complicated. You don't have to convert it to polar. I'm gonna skip polar. They say convert. Hey, now it's getting tough. So now add slides. I'm gonna add another slide. So they say whatever that you got, that exponential, I'm gonna write xp, convert it to rectangular. Rectangular, you must remember that it was like this. It's a plus bi. You need this. There's no r there. But in your exponential form, you've got this. That's the difference now. I, theta. Hey, it's a problem. This is what you're gonna do. You see, you saw that formula that I told you about. This, the one that I said it's in the middle, it's in between. That's the formula that you're gonna use. This one. This formula right here. This is the formula that let me just do this. This formula, the one that you're gonna use. This is the formula that you're gonna use. Okay. So you have to write that formula down. Z equals to R into, okay, you write your cos theta plus I sine theta. You see why you have to use this formula from converting from polar. So basically this formula is back to back. You can convert from rectangular to polar, or polar to rectangular, or exponential to rectangular. So you use this formula to convert from exponential to rectangular. You know why? Look at this. Or converting from, yeah, it's polar polar to rectangular. Or let me write the notes on the side so that you can remember. So this formula right here, it's for converting from polar to rectangular. You know why? Because at the end of the day, you're going to put your R there. You're going to put your theta. So whatever that you're going to get here, you're going to get a number. Then for this one, you're going to get imaginary number. There's your real number and imaginary number. So it's more like your A plus BI. Make sense? Yes. So that's that. Then also you can use this formula to convert from, you see the formula, you look at the formulas that has got R and theta. It's only polar and exponential. So you can use this formula to convert from exponential to rectangular. Because in your exponential you've got angle, this angle, but then this angle for exponential it's in red. So you need to convert that angle back to degree. Okay. So now let's work. We are converting this value. It was 5.1. This is not theta, guys. It's e. It's e to the power I theta. E to the power minus 0.2 I. So we need to convert that to rectangular. You see there, you've got your R. This R is constant, but the problem is this angle. You see that angle there? That angle is in red. I'm gonna write red there. It's in radian. So you need to convert that radian angle, because for for rectangular you need this theta in degrees. The only time you use radian angle, it's when you are converting to exponential. So let's convert that angle. So we're gonna say theta equals to, remember I'm gonna write this standard formula. Okay, I'm gonna do this. Remember I said you must write red equals to, when you convert from degree to red, you have to say degree times pi over 180. So now we are looking for this. We are not looking for red. This is the standard formula for converting from degree to radian. So now we have to make that deg the subject of the formula, because why? You know the degree. Your angle is in degree. It's in red, sorry. Your angle is in red. So you need to convert it to degree. You know this value. So the unknown value is the degree. So you're going to say deg, make that deg the subject of the formula. How do you make that the subject of the formula? You have to cross multiply here. You multiply both sides by 180 to cancel this. You multiply by 180 over pi, 180 over pi. And then this and this will cancel, obviously. So your deg, your formula will be deg is equals to red times 180 over pi. Does it make sense? Any question? If you have got any question, please let me know. Please let me know. It's not that difficult, guys.
Teacher Dave,
Yeah,
so
boy.
the degree equals rad times 180 over pi. Is that our exponential to rectangular, or is that just a part of the equation that we need?
No, I'm just converting because I
Oh,
said
okay.
for in order for you to convert to rectangular, your angle must be in degrees. So you have to convert that angle to degrees. The angle that I wrote red, you see that angle where I wrote red in exponential from exponential, that minus zero point
Uh,
0.2.
yes, I see it. Minus
Remember,
0.2, right?
remember earlier we converted that angle to red. So now I said just because you are going to rectangular, you have to convert that angle back to degrees because in rectangular you're using degrees. And that's what I did there. I made that degree the angle, that degree angle, the subject of the formula, so that we can get that value minus. You must get that minus 11.51 when you calculate here.
Yes.
You are going
Okay, I see, I see.
you are going back to that.
Thank you, Teacher Dave.
Sure. So it's minus 0.2 multiplied by 180 over pi. So if you punch this, guys, you must get minus 11.31 degrees. That's what you must get. This thing keeps on coming back.
Yeah. I got 11.45.
I think there should be a mistake there.
If you use the unrounded off number, you'll get to 11.3.
Yeah, must round the numbers off. Please round the. You see now. Why is this thing appearing, guys? Does anyone know? It keeps on mixing this thing. What should I do? I don't know what to do now.
You didn't copy something, Teacher Dave. Maybe it's pasting the whole time.
Oh, and you're right. It's that thing that I copied earlier on. It keeps on pasting.
Okay.
But I'm not pasting it. Why
Cool.
is it pasting? Because I'm not pasting it.
Stuff happened, Teacher Dave. It's okay.
Aish. Okay.
Maybe you can undo something. I'm not
I
sure.
tried to
Yeah.
undo, but then it doesn't work. No, don't worry.
Oh, okay.
I'll just do this.
Cool.
So you got your angle. Everyone got that angle. That angle in degree. That minus 11.31 degree. You got it, right?
I got it.
Everyone? Everyone got that one. Everyone got it. Yes, no? Okay, no response. Okay, that means you're sorted. And then your R,
Yes.
then your R is 5. So you're gonna substitute those values. You're gonna say 5 into cos. You put that minus 11.31 plus I sine minus 11.31. Here's what you do, guys. Don't do it all at once. If you remove the brackets there, you must know that you're gonna have 5 cos minus 11.31 plus 5 I sine minus 11.31. Do this one separate. That's your A. From that formula where it says A plus BI, you're going back there. Then you do this one separate. That's your imaginary, your I. And then this is your number. This is your A, this is your BI. Ish, this color is not visible enough, guys. I know some of us, we are color blind. Hey, nah, hey, I can't see this light colors. So this is your A, this is your BI. Punch this on the calculator. You should get that from there. You still remember what we got there from your A. You still remember that rectangular value that you got earlier?
Didn't
You
didn't
wrote,
we get 5 for the A and -1 for B? Wasn't it
yes,
that?
you must get that. Are you not getting it? When you say 5 cos minus 11.31, if that's the value that you got earlier, okay, let me punch it on the calculator. Where is that calculator? Are you guys not getting it?
I'm getting a negative I instead of positive.
No, guys, look at this.
Oh yeah,
Say
yeah.
5 cos
Yes.
cos minus 11.3. You're gonna get 4.9. 4.9, if you round it off, it's 5.
Mm-hmm.
If you round it
Yeah,
off,
got it.
you should get 5. Here,
Teacher Dave,
I
what are we putting by the I?
no, you just leave I. You only put the value. I, you're gonna put it after. It's like you find B.
Okay, thank
You
you.
don't put anything there. You just say B. I, there's nothing you can put on for I. The value that you're gonna get, you must get I into something. That's your B. You're gonna put your B there. That value must be 1. If you say 5 sine minus 5 sine minus 11.31, you must get -1. You see there, it's minus 0.98. What? You round it off. It will give you 1. Minus, it's 0. Okay, yeah, it's plus minus 0.9. Is it minus 0.98? If you round this off, it's the same. It's 5 plus, okay, minus, okay, minus 1. So you just say 5 minus I. Makes sense to everyone.
Yep.
Teacher Dave, I'm so sorry. I typed in 5 cos minus 11.31 plus 5 sine minus 11.31, and I got 3.92.
Mm-mm.
I'm not sure if I'm just confused.
Do this. That's why I made them separate. Remember when I highlighted in yellow? I said this one, it's one part. It's only one part. Don't add them because of I. You do them separate.
Oh,
Because of I, they are separate values. They are not the same values. It's not like terms. You know this thing is the same as, let me show you. You can't add x and y. So this, it's more like 5x plus 5y. You see there isn't the difference. The difference is that this one has got I. That I, it's more like y. You can't add this because they are not the like terms. Remember when we were adding this, we said add them separate. Like we had to do this. We had to say 5 plus 3 plus I. We add the imaginary numbers separate. We say 5 plus 3. The reason why we're not adding them all at once is because of some of them they are imaginary, some are real numbers. So you can't mix the two. You have to add them separate. So you just punch 5 cos minus 11.31. Should get that 4.9 and a positive one.
I got it. Thank you so much, Teacher Dave.
Sure. Okay, so guys, you see that it's proven? It's proven. Any other question? For sure you guys now are sorted. Even when you want to go to polar, your angle must be in degrees. Let's move. Subtraction. Guys, this thing keeps on appearing. What's happening? I copied that thing. How do you remove this thing that you copied?
Teacher Dave, maybe you should just copy something else so that it doesn't keep copying the full thing. I don't know, maybe you should just copy a letter or something.
Okay, let me try to do this.
Maybe copy theta or something.
Okay, let me copy this one. Copy. Then after copying, I must paste.
You can just test it. I'd say paste it just to test if it really pastes.
Okay, let me try to do this. Say paste. Ish. It's a problem. I don't know. Let me close this thing and open it again. There's no other way. I'm gonna say don't save, guys. I'm gonna say don't save because I have to open it again so that when I open it again, you see those that are doing engineer mechanics, we're gonna work. Is there anyone who's doing engineer mechanics here? That engineer yeah. You see now.
Who's doing what?
Engineer mechanics.
Engineering mechanics.
Elementary what? Mechanics, engineering mechanics, physics, or sometimes they call it EME 1501, PHY, what. They've got different codes.
Yeah.
Yeah, we'll meet. I think, yeah.
Yes.
Okay. So I know Pink is doing it. I know most of them they're doing it.
Yeah.
Yeah, and it's a difficult one.
No.
It's a difficult one. Okay, so guys, here we are subtracting. We are adding, now we are subtracting. This is the formula that you're gonna use. So guys, I don't want to spend more time on this subtracting and adding. I'm not gonna do subtracting, guys. I'm gonna move straight to division because that's what it's on your assignment. Subtracting is easy because you just replace the sign. It's only the sign that changes. You just remove the brackets there. Okay. Here you just say you add the values. You say I into. You see this, you're gonna have to multiply everything by that negative. So let's remove the bracket first. I'm gonna do this one quickly. I'm not gonna spend more time on this. You're gonna say 3 plus 2i minus 2 plus, when you remove the brackets, what did I do now? When you remove the brackets, this one it will be positive 3i. Then you're gonna add those values. The I will be one side. You're gonna say 2 plus 3. Then you're gonna say plus 3 minus 2. Then that's how you do it. There's no question there, guys. It's just the subtraction. Same applies to multiplication. That thing appeared again. You see now. How do I do?
Teacher Dave, so the subtraction, we just we times the minus into the bracket, and then we do a normal addition of complex numbers.
Yeah.
Okay, cool.
Okay, I'll stop copying this thing. I think the problem is that thing that I copied because it keeps on pasting the same thing. So guys, the multiplication, you're gonna multiply the like terms. So basically you're gonna do the same thing. You see this bracket, it means multiplication. So you're gonna say 3, you multiply the like terms. The same ones. So you're gonna say you're gonna multiply the I values. So you're gonna multiply the I values. It's 3 multiplied by the I values is, no, it's 2. It's not 3. It's 2 multiplied by minus 3. Then you multiply the I values, this one. It's this one times this one. Then you say plus into, you multiply now the other real numbers. So you're going to say 3 times 2. Z equals, remember this minus, this plus, I just put this plus. This sign can change. It will depend on this value. It can change. Like for example, now we're going to get minus 6i. Then we're going to say plus 6. So if you write it in a standard form, you'll have 6 minus 6i. That's how you do it. That's your multiplication. You multiply the like terms. And then let me see if there's anything interesting here. I showed you how to do this one. I showed you how to convert this one.
Sorry.
Yes. I can't hear you. I should go back. Hey, you see what? You see when I go back, that thing that I copied. I can't hear you. I don't know if it's your mic.
No, I wanted to.
Are you using the headsets?
Yes, I'm using.
Please try to remove the headsets and put them back on because I can't hear you properly. Let's try that. Hopefully it will work.
Hello?
Sure.
Okay, is it sharp now?
Yeah, it's sharp. Perfect.
Oh, okay. I wanted to ask in the multiplication, sir.
Mm.
Then aren't you supposed to say 2 times 3 and then that outside multiplication and then you say, like, for example, we're going to start with
Oh, yes.
3 times 2 and then 3 times 3.
Yes, you remove the
After that, you say 2 times 2 and then 2 times 3.
yes, you remove the brackets like that. You remove the brackets like that. Sorry about that. You remove the brackets like that. You remove it like this. This times this. This times this. This times this. This times that. You expand it. But the shortcut, is this one. The way I did it. The way I did it. Sorry. There's a shortcut. The way I did it, there's a shortcut.
You said the way you did it is a shortcut.
There's a shortcut. You add the middle term.
So how okay, in your shortcut, how
You're gonna get another value that is I squared. It's minus 6 squared. You do this. Minus I squared. You do this. Look. You multiply the first terms. Basically the middle terms. Remember, the point of doing this, it will give you a x squared plus bx plus c. So what this means is that you multiply the first values, the middle term, the first ones. Sorry, the middle term, you'll get minus 6i squared, right? That's your, what do you call it? I don't know what do you call this. Is this parabolic function? The one where you've got ax. Remember this formula. What do you call this formula? Quadratic. Yes, this is a quadratic equation. I remember it now. This is a quadratic equation. So your middle term is going to be this times this, and then this times this. Then you subtract them. So basically it will be minus 3 minus 9i plus 4i. Then you just add these values. I don't like writing these values. This ones, they just chow time. Then you say plus 6. This is your last term. This is your first term and your last term. The middle one, you just find it by multiplying these two. You multiply this one with this one, and then you multiply this with this one. That's how you find your middle term. You just add them on a calculator, or you can show the steps. For you guys, you have to show the steps. But then if you are doing maths 3, maths 2, I don't have to show that middle term. This one, this one, middle term. You don't have to show it. You'll see these things when you get to division. When we get to division, you'll see that if the functions are the same, there's no need for you to show the middle term. I'll do an example for that one. So z will be equals to minus 6. What is I squared? Does anyone still remember?
Sorry, teacher Dave, I've got a quick question.
Hmm. Yes, you may ask.
Teacher Dave? Sorry,
Yes,
man, I've got a quick question.
yes, I'm listening. Anton, is it my network, guys?
Sorry, man. I saw the short method was 6 minus 6i. Yes.
6 minus 6i. Anton, guys, I can't hear anything. I can't hear Anton. Can you guys hear me?
Yes, teacher Dave.
Okay, they are saying the network is fine. So Anton, what were you saying?
So I got 6 minus 6i, but the long method, I see there's a square. There's a square.
Yeah,
Minus 6i squared.
the square should be there. The square should be there. You can't remember. Can you hear me, Anton? Guys, can you guys hear me?
Yes.
I don't know if it's Anton's network or my network.
Yeah. Okay.
I don't know if it's my network
Yes.
or Anton's network. But there's a problem because there's a delay on his side. I need to be sure because Anton, I can hear Anton, but then I think there's a delay. So guys, for your middle term,
Maybe it's his network.
yeah, maybe it's his network. If you can hear me, then it's his network. What is I squared, guys? Do you still remember? It's there on the formula sheet. They said it's minus 1. I squared.
It's minus 1.
Yes. They said it's minus 1. So you're gonna put minus 1 there and say minus 5i plus 6. So your z is gonna be equals to 6 minus 5i plus 6. Then you're gonna get minus 5i. That's your answer. That's how you do it. Someone who corrected me, thanks. Hey, I was using this division method. When you do division, let me show you with the division why I did that. With the division, you only consider the first and the last term. You don't consider the middle term. What is that division? Guys.
Is it not 12? Is it not 12 minus 5i?
Why?
Huh?
No, it's minus 6 here. Oh, it's okay. It's 12. Hey, I thought it's minus 6. This one. It's positive 6. 6 plus 6, 12. 12 minus 5i. This 6 plus this 6. It's 12. That's your 12. This 6 will change to positive. This one. This one, it will be positive 6. There is a positive 6.
But is it not -1 squared?
Where? No, it's not -1 squared. Remember, we replaced this, we replaced I squared. We replaced I squared. We said where there's I squared, we're going to put -1.
Okay, I'm with you. Thank you.
Sharp. Oh, Anton, I squared. Remember when I started this thing? When I started earlier, when we started this thing, I showed you guys that I showed you that I squared from the formula. They wrote this thing there. They say there where it says where I is equals to -1, and then I said if you've got I, it will be equals to square root of -1. Then if they want I squared, you're gonna have to square both sides. You take this, you square it. So you're gonna say square root of -1 all squared. Then this and this will cancel. You're gonna be left with -1. That's why I squared is equals to -1. I did that earlier on. So
Thank you so much.
sure. So I wanted to do yeah, this is the part that I want. So guys, they say you see from in your assignment they said you must leave this in this form. You must leave it in this form. 3I, it must be A plus B I. You must leave it in that format. Don't write it in polar form, don't write it in any form. If they said leave it in that form, you must write it as it is. So guys, if you have got a division like this is your rectangular. In a rectangular, when I've got a division like that, you're gonna say z equals to 3 plus 3I. 3 minus 3I. This is what you do. You're gonna say multiply by 3. You see this, you're gonna take your denominator. You're gonna multiply with that. You're gonna say change the sign. The sign that you change is this one for I. You change the sign of I. Don't change the sign of the real number. You change the sign of the imaginary number. If it was negative, there you're gonna put positive. See, here it's negative, here it's positive. You change the sign of I only. So you're gonna say plus 3I. That's how you do it. Or alternatively, we're gonna do the alternative method where you convert it to polar. Then after converting it to polar, you can divide. It's easier. With polar, it's faster. But then it's up to you which method you prefer. So since in this case they said you must put it in this form, there's no other way you can do it. You have to follow this method. So you're gonna say 3 plus 3I multiplied by 3 plus 3I, all divided by all divided by. You see the part that I was talking about. This is the bottom part. This part here. 3 plus 3I. You see there, you've got same functions but different signs. That's why you apply that method that I did earlier. The middle terms are gonna cancel. You're only gonna write the first and the last term. I'm gonna show you how to do that. So Z will be equals to, guys, it's half past. I have to wrap up. Got another session. There's You're gonna have to remove the brackets there. You're gonna say 9, then the middle terms it will give you 3 times 3 plus 3 times 3. So 3 times 3, 3 plus 3, you're gonna get 6. You're gonna get 12I for your middle term. Then the last term you're gonna get 9I squared divide by, you see here, because of these signs, they are different. You can expand it. I'm not going to expand this thing. You can remove the brackets there. But the answer that you will get is this one. It's 9. You only multiply the first term and the last term. So when I say the first term and the last term, you only multiply this one times this one only. That's what you do. 9, 3 times 3, the answer. The numbers, then you say minus 9i squared. That's what you do. The middle terms are going to cancel. That's the quickest method. Same functions, opposite angles. They cancel. So you're going to say 9 plus 12i plus 9. Where there's I squared, we said you put minus 1. Divide by 9 minus into minus 9. Minus 1, sorry. Then your z will be equals to. For your top part, it's 9 minus 9. So you're going to get 12i for your top part. Then the bottom one, you're going to get 9 plus 9. You're going to get 18. Then that's how you do it, guys. Then you can obviously divide these values. You can divide 12 by 18 if you want. Then you'll get your values. It's 2 over 3. 2 over 3. Then you put your I there. Any question? Any question, guys? Any question? Can you guys still hear me?
Yes, teacher Dave. Can we use the short method? Can we use the short method?
Yeah, this is the short method that I was talking about. I did that, miss. Here, I said instead of you expanding this thing, the bottom part, this one, I said you only multiply the first and the last term. And then you got to this. Instead of you removing the brackets there, you just say the bottom one, multiply the first and the last term because
Thank you, teacher Dave.
the same, it's the same functions, but then different signs. So the middle terms will cancel. Even if you expand it, you'll get the same answer. You can expand it, you'll get the same answer. I'm just showing you how to save your time. You do that. And then that's how you do it, guys. Then let me do the last one before we wrap up. This one. I know it's there in your something similar to your assignment. This one, guys, if you go through your study guide, you'll see these things. So here you take out your factors, you divide them. Do you guys still remember that method that says dividing the parts of the same base, you subtract the exponent? It's more like you've got 5x squared over 5. Okay, let me not write 5 over 6x. Dividing the parts of the same base, you subtract the exponent. So you're going to say 5 over 6 into x squared minus 1. Because this one is to the power 1. You divide the exponent. You subtract the exponent, sorry. You divide the factors. That's what we're going to do. So we're going to take the like terms, this one and this one. So that's what you're going to do. You're going to say cos pi over 3 minus pi over 2. Then we say plus 3 over 5 into I sine pi over 3 minus pi over 2. And then you get your answer there. You're going to get 3 over 5. For cos, just punch that on the calculator. You just punch those values. So you can say 1 over 3 minus 1 over 2. You just punch this, guys, on the calculator. So you'll get minus 1 over 6 Did you all get that? Minus 1 over 6 pi. You know what I did, guys? I just said, yeah, even if you do it with pi, it's fine. Just ignore the pi, ne? Just say 1 over 3 minus 1 over 2. Because the pi is common on both.
Minus 1 over 6 pi.
Yes, minus 1 over 6 pi. You just ignore the pi. You say 1 over 3. You take the coefficient. You take 1 over 3 minus 1 over 2.
Yes.
Yes, don't put pi. Pi, you put it after when you multiply. It's more like you're using it as I. So, I'm going to say plus 3 over 5. I sine minus 1 over 6 pi. And then z equals to, you just punch this on the calculator, guys. Just because, guys, this thing, it's here. Let me show you. It's in your book. There's something similar. I was on that page before I went to that formula that I showed you, how to convert to red and all those things. I was on that. I've just highlighted that thing. Where is it? Just highlighted similar problem. It was similar. Division, this one. This is the formula. It's on page 121. That's how you do it, guys. You just subtract, you see? That's what they did. Example 4. But they were using, instead they were using the, you see, they were using the degrees. In our case, we're using the pi and all those things. So your answer, you know your answer already, mas. You're just gonna get to this part. You know your answer. There's more examples. You can go through those examples whenever you have time. There's more examples. I just wanted to show you this. So let's get back to work. So you can just write this. You can just punch this on the calculator. So you see now, you've got pi. If you want to use pi as it is, guys, just write this down. For pi, the moment you see your angle, that angle as pi, just know that your calculator, you must put it in red. If your angle it's in pi, cos theta, that angle there, if it's pi, you must convert your calculator to, you must put your calculator to red. And to put your calculator to red, or you can convert this. Let me show you.
Stop sharing the screen.
Sorry?
You stop sharing your screen. You have stopped sharing your screen.
How? What happened, Kanti? Is it sharing now? It will present just now. I don't know what happened.
No.
It will appear just now.
Okay, it's fine.
Is it fine now? Is it appearing? Yes, no? Guys, is it appearing? Hello? Yeah, now. Now it's appearing, right? You should see the screen now.
Yes, it is.
Okay, sharp. So I was saying the angle. I don't know what happened, but then it stopped. I don't know. Automatically. I don't know why. And you can hear me, ne? Can you guys hear me? Can you guys hear me? Yes, no? But now it's back on the screen.
Yes, we can hear you, but you cannot see your screen.
But now you can see it. I don't know what's happening. This thing stops presenting. You see?
No.
Okay, let me try to present again. It disappeared again. I don't know why. Let me try to present again. It will appear just now.
Or maybe it's a network.
Ne? Maybe it's the network. You're right. Let me stop this.